Okay, now we look at multiplication of exponential numbers, but our exponents will only be positive exponents. We use positive exponents. Okay, before we understand this very, very well, I want us to first perform some kind of investigation that will lead us to the properties of exponential numbers. Let's do some investigation. Okay. Now, if we have let's say we call it number 1. We have 7 squared times 7 cubed. 7 squared times 7 cubed. So we know that 7 squared means 7 times 7, right? So what about 7 cubed? 7 to the power of 3. What does it mean?
7 times 7 times 7.
7 times 7 times 7. That's correct. So you can see that we are having all together as 7 times 7 times 7. You know, let me write it again very well. Like 7 times 7 times 7 times 7. How many times?
5.
5.
Yes, it should be altogether 5 times. Okay, so now I have 7 to what power?
7 power of 5.
7 to the power of 5. And you see that 7 to the power of 5, it is the same as 7 to the power of 2 plus 3. Do you see that 2 plus 3 will give us 5? You see that?
Yes.
Yes.
Okay. We'll look at another example. Let's call it part 2. If we have 6 squared times 6 to the power of 4. Of course, we know that 6 squared is 6 times 6. What about 6 to the power of 4?
6 times 6 times 6 times 6.
6 times 6.
Okay. So in the next step, so we have 6 times 6 times 6, 6, 6, 6. How many times?
6.
It should be 6 times. Okay, so it means that we have 6 to the power of 6.
6.
But 6 to the power of 6 is the same as 6 to the power of 2 plus
4.
plus 4. Very good. You see that when we expand it, we get 6 to the power of 6. But 6 to the power of 6 is the same as when we get 6 to the power of 2 plus the power of 4. Now think, if we have part 3, like let's say if A is a rational number, Then we have got a to the power of 3 times a to the power of 4. By the way, I want you to note what we call a rational number. A rational number is that number that can be written as a fraction. For instance, what we looked at previously, integers are rational numbers. Fractions are rational numbers. Decimals like 0.2, 0.3, all of those are rational numbers. So, remember, there are some numbers that cannot be written as a fraction. Those are called irrational numbers. But here we are dealing with only numbers that can be written as fractions. Now, so when I say if a is a rational number, it means that this a, maybe it is an integer, positive integer, maybe it's a negative integer. Maybe it is a fraction. Maybe it is a decimal. I don't know what a is, but I know that a is a rational number. You understand? So how can we get to do this? Like how we have done number 1 and number 2. If a is to the power of 3, it means that I have a times a times a 3 times, right? What about a to the power of 4? What do we have?
A times A times
A times A times A.
Yes, 4 times. So it means that all together, when we put them together, we have a times a times a times a. How many a's all together?
7.
7.
Yes, so it means that we have a times a 7 times. 7 times. So what is our answer then? A to the power of
7.
7.
So this is the same
Ồ, mọi người nào?
a
Nào.
to the power of 3
Nào.
plus 4. Pirapat,
Con có mình
please.
nghe nó tạo nó sẽ tạo.
Pirapat, you can pause you can turn off your speakers. So student, do you understand this?
Yeah.
Yes.
This is the same as number 1, number 2, and number 3. So you see, from this, we are going to now come up with the property of multiplication of exponents. We are going to get a formula that we can always use. Look, let's have this as part 4. Still, if we say that a is a rational number, it means that I don't know a, but I'm sure that a can be an integer, a can be a fraction, or a can be a decimal. At least I know that. So if a is a rational number, then m and n are positive integers. I know a is a rational number, which means that it can be an integer, it can be a fraction, it can be a decimal number. Then m and n, for them are positive integers. Then if I have a to the power of m times a to the power of n, what do I have? What do you think? It means that I have a times a times a. How many times? We are writing a to the power of m. It should be to the power of m. So it means that it is a times a times a, m times. You understand that? If m is 10, then it will be times 10 times. If a is 2, it will be times 2 times. Okay.
Okay. It's then it just confused at in the first time.
Yes. Yes. If this m is like 2, then it will be a times a. If m is 10, it will be a times a times a times a times a 10 times. So because I don't know what m is, so that's why I'm saying m times. You understand that?
Yes.
Okay.
That's weird.
Yes. Okay, then a, we are writing a to the power of n times a to the power of n is a times a times a. How many times?
N.
Very good. N times. So what do you think? A to the power of m times a to the power of n. What does it mean? Okay, let's do it. Let's combine this together. So we have a times a times a times a. How many times? If we get all this together, how many times? It should be m plus n times. You understand? Because if a is like 2 and n is like 5, then it should be 2 times 5. So it should be 7 times. You understand?
Yes.
Yes.
Okay. So now it implies that we are having a to the power of m plus n. Like what we have been having, like a to the power of 2 plus 5. Now, this will give us the law 1 of exponents. Or like the first law of exponents. What does it say? It says that if a is a rational number, then m and n are integers, then a to the power of m times a to the power of n is equal to a to the power of m plus n. Let's apply this into an example. Let's use it in an example. Let's have like example 1. Let's say that we have got like simplify 5 to the power of 8 times 5 to the power of 9. So we are having our solution as our question is 5 to the power of 8 times 5 to the power of 9. So if we apply our first law of exponents, it means that 5 to the power of 8 is the same as a to the power of m. You understand? Is it okay?
Okay.
Then 5 to the power of 9 is the same as is the same as a to the power of n. So it means that if I have 5 to the power of 8 times 5 to the power of 9, I have got 5 to the power of 8 plus 9. Like when I have a to the power of m plus n. M is 8, n is 9. So what is your final answer?
5 power of 17.
Very good. 5 to the power of 17. Let's have another one. Number 2. We are going to simplify all of these and we let our answers remain as exponential numbers. We are going to write them in exponential notation. So let's say we have -2 to the power of 3 times -2. Or you can call it -2 to the power of 1. So what do we have?
Negative 2 power of 3 plus 1.
Okay. So we have -2 to the power of 3 plus
1.
1. Very good. Because -2, this -2 is to the power of 1. But -2 to the power of 1 is the same as -2. So that's why we don't write the power of 1. So we have got -2 to the power of
4.
4. Very good. Okay, let's have number 3. Let's say that we have 6b to the power of 3, c to the power of 5 times 2b c to the power of 4. So we assume that b and c are rational numbers. Let's just write it there. Given that b and c are rational numbers. So like how we have been answering our questions. So we have got 6b the power of 3, c to the power of 5 times 2b to the power of 1, c to the power of 4. So for this one, let's have 6 times 2. What is 6 times 2?
12.
12. Then times b to the power of 3. Now we bring another b times b times c to the power of 5 times c to the power of 4. Do you understand that?
Yes.
Okay. So we have 12 times b to the power of 3 plus
1.
1 times c to the power of 5 plus
4.
4.
So our final answer is 12 to the power of 12b to the power of 4, c to the power of 9. Do you understand that? Okay. I will give you another example that is the same as number 3. You can get used to it. Let's say we have got 2x y to the power of 4 times 3x to the power of 5 y to the power of 3. How do we get to answer that? Mm-hmm. 2xy to the power of 4 times 3x to the power of 5 y to the power of 3. So what do we have?
2 times 3 is
3 is 6
Uh-huh.
times
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 x
x
power of
5
Mm-hmm.
times
y
y power
power
of 4
Mm-hmm.
times y
y
power
of
of 3
3
Okay. So next,
6 times
x
x power of
of
5
5 plus 1
5 plus 1. Mm-hmm.
times
y
y power of
4
4
Mm-hmm.
plus
plus
3
3
Okay, very good. So what we have next?
6
x
X,
x
the power of
power
X.
of 6
mm-hmm.
y
y
power
power of 7
Very good. Do you all understand?
yes
Okay.
yes.
Okay. And let me give you the last kind of example. If we have like a to the power of 12 times a to the power of 8. What do you think about that? We have
A power
No.
of 20
yes, a to the power of 20. That is a to the power of 12 plus 8, and that is 20. Have you understood that?
yes
Okay, I think this is very easy, right?
yes
Yes. Okay, now let us look at division. We have just finished multiplication. Let us do division. Let's say division of exponential numbers. Division of exponential numbers. And we are going to deal with positive exponents. Positive exponents. So in other words, it means that all our powers will be positives. We shall not have any power that is a negative. However, no problem even if it is a negative, but we are going to look at how to deal with negatives later along in Matter 2. For now, we are going to deal with positive exponents only. But if you need to know about negative exponents, you can check on our YouTube channel and you check for Matter 2. Already it is there on YouTube. You can check and you know how to deal with negative exponents. But for now, we are going to be dealing with positive exponents. Let's do some investigation this investigation will take us to the second law of exponents. Okay, so let's say that this is number 1, and we have got 3 to the power of 5 divided by 3 squared. We know that if we have got 3 to the power of 5, it actually means 3 times 3 times 3 times 3 times 3. 5. Yes, 5 times. Is that okay?
Okay.
So what do you think? I can write divided by like this, okay? I can say that 3 to the power of 5 divided by 3 to the power of 2 is the same as 3 to the power of 5 out of 3 to the power of 2. Do you know that? This one, It's like if I have 2 out of 3 is the same as 2 divided by 3. I think you know this already, right?
Yes.
Okay, so that's why I'm writing it like this. Okay, so 3 squared. We know that that is the same as 3. Oh, can you see this color? It's kind of dull. Let me change the color. Three times 3. Is that okay?
Okay.
So what do you think if I reduce them? This 3 will go with this 3. This 3 will go with this 3. So how many 3s do I have left?
3.
3 3s, right? So it means that I have 3 to what power?
To the power of
3.
3.
I have 3 to the power of 3. Now, do you know that 3 to the power of 3 is the same as when I get 3 to the power of 5 minus 2? Do you see that?
Yes.
Yes. Okay. You remember when we did multiplication, we were adding, we were using plus, we were adding the powers. But now you see for division, it's kind of maybe we have to use minus. But we cannot rule it out that we will be using minus. Let's get another example before we conclude that, okay, we have to use minus. Okay, let's say that I have 10 to the power of 6 out of 10 to the power of 4. So 10 to the power of 6 divided by 10 to the power of 4. So what do I have? 10 times 10, how many times?
6.
6.
6 times. 1, 2, 3, 4, 5, 6. Out of 10 to the power, sorry, out of 10 times 10, how many times?
4.
4. Okay. 10 times 10 times 10 times 10. Okay. So let's reduce these 10s. This 10 will go with this 10. This 10 will go with this 10. This 10 will go with this 10. And this 10 will go with this 10. So what do I have left?
10 power of 2.
10 power of 2.
10 to the power of 2. But you know that 10 to the power of 2 is the same as 10 to the power of 6 minus 4. You see, 6 minus 4 equals 2. You see that?
Yes.
Okay. We try another one. Let's use A. Let's say that we have A to the power of 7 divided by A to the power of 3. So what do we have? You can tell me as I write. A times A, how many times?
7.
7.
7 times. 1, 2, 3, 4, 5, 6, 7. Okay. Out of A times A, how many times?
3.
3.
Okay, A times A times A. Okay, so I have A to what power?
Power of 4.
Power of 4, because this A and A will go, this and this will go, this and this will go. I have 1, 2, 3, 4. So I have A to the power of 4. But this is the same as A to the power of 7 minus 3. Okay?
Okay.
Okay, now assume that A is a rational number, and I have A to the power of M divided by A to the power of N. I don't know how many times are M, and I don't know how many times are N. So I have to say that I have A times A times A times A. How many times?
M.
M.
Very good. M times. Out of A times A times A times A, how many times?
N.
N times. So what can I say? How many A's do I have? It means that I have A times A times A times A. The total number of times will be M minus N times. Is it okay?
Okay.
Okay.
So it means that this is the same as A to the power of M minus N. Understood?
Yes.
So therefore, we are getting the second law, law 2 of exponents. So it means that A to the power of M divided by A to the power of N is equal to A to the power of
Minus N.
minus N. That's good. Remember the first law. Law 1 is A to the power of M times A to the power of N equals A to the power of M plus N when we have times. But when we have divided by, we get law 2, A to the power of M divided by A to the power of N equals A to the power of M minus N. Is it okay?
Okay.
Okay. Now, let's get some practice questions. I'll give you about 3 questions. And then we can stop here and we continue next time. Let's have example. So number 1, we have got 7 to the power of 8 divided by 7 to the power of 3. So what do we have? Very quick, very quick, very quick. This is equal to
7 power
7.
of 8 minus 3.
and the answer will be
7 power of 5.
7 to the power of 5. Understood?
Yes.
Okay. Number 2. Let's have -5 to the power of 6 divided by -5. Okay, so what do we have?
-5 power of 6 minus 1.
Very good. And then our final answer will be
-5 power of 5.
-5 to the power of 5. Did you understand, everyone?
Yes.
Yes.
Okay, now this is our last example. Let's call it number 3. Let's have 12b to the power of 6, c to the power of 3 divided by 6b to the power of 4, c. Let me write this for very well. b to the power of 4 and c to the power of 2. Oh, yes. So what should we get?
12
12,
Divided by
6.
6.
power of
Yes. 12 divided by 6, right?
6.
Okay. What is 12 divided by 6?
2.
2. So it means that we will get 12 divided by 6, which is equal to 2. Okay, so I write 2. Then I have b to the power of 6. Get b to the power of 6 and b to the power of 4. So I write b to the power of 6 minus 4, right? Is it okay?
Okay.
Then I write c to the power of
Power
3
of 3 minus 2.
very good. I get c and c. So I have c to the power of 3 minus 2. What is our final answer?
2
2
b
the power of 2
2
c
c
power
power
of
1.
c to the power of 1 is the same as c,
3.
right?
Yes.
Understood?
Yes.
Yes.
I think I should give you the last one that is the same as number 3, because I don't want to give you exercise and you have like kind of a problem. Let's repeat an example that is the same as this. We have 27 x to the power of 9 y to the power of 4 divided by 9x to the power of 6 y to the power of 3. Very quick, what should be our answer? 27 divided by
3.
27 divided by 9. What do we get?
3.
3. Next, we have
X power
x to the power of
of
9 and
9
x to the power of
minus
6. So I write
X power of 9
9 minus 6.
6
very good. Then next I have y to the power of 4 and y to the power of 3. So what should I write?
Y power of 4 minus 3.
Okay, so what is our final answer?
3
3x power of
3
3 and
y.
y power of y.
yes, y to the power of 1 all the same as y. Have you understood?
Yes.
Yes.
Okay, so that's very, very, very good.